In this video, I'm going to just quickly explain the difference between catabolism and anabolism. You would have heard of metabolism. Metabolism is the underpinning thing. You measure metabolism, that will then diverge into catabolism and anabolism. Catabolism is the breakdown of products. You can imagine that. Catabolism, it sounds like catastrophe. It sounds somewhat destructive in a weird sort of way. And so that is the breakdown of products. Glycolysis is a catabolic process. Gluconeogenesis is an anabolic process. One is building up glucose from 2-pyruvate. One is breaking down glucose into 2-pyruvate. These are two separate processes. One is catabolic, one is anabolic. Catabolic will break down things such as fatty acids into acetyl-CoA, but an anabolic process would be fatty acid synthesis, where essentially the reverse of this process happens, where acetyl-CoA molecules can combine and reform to form fatty acids if your body needs them. That is an anabolic process. That is the build-up of fatty acids from a literal 2-carbon unit, as well as the sort of coenzyme thing, but that is a whole sort of separate topic that I'll talk about in, I don't know when I'll talk about that, sometime in the future, I guess. But another anabolic process would be the build-up of proteins from intermediates of the Krebs cycle. Things like acetyl-CoA, things like alpha-ketoglutarate. These can be anabolically transferred. These can be transferred out of the Krebs cycle if they need other things to make up proteins. Things like pyruvate, that can be built up into proteins. Pyruvate has loads of things that it can do. It's such an interesting molecule. Pyruvate can go to turn into acetyl-CoA. It can turn back into glucose. It can form a lot of amino acids as well. Such an interesting molecule. And that would be an anabolic process. Pyruvate turning to acetyl-CoA is catabolic, but pyruvate turning into certain amino acids, that would be anabolic, as it is the building up of amino acids from that one sort of base 3-carbon pyruvate is molecule. A lot of amino acids are completely essential, meaning your body cannot synthesize them. When these essential amino acids are broken down to produce energy or to do other things, your body cannot get back up to produce them. Your body cannot produce it from acetyl-CoA. Your body cannot produce it from pyruvate. Your body cannot produce it from glucose. Your body cannot produce it from intermediates of the Krebs cycle. Your body cannot produce it in any way, shape or form, at least in a sufficient amount whatsoever. So your body will have to ingest these from the diet. They can only be catabolically metabolized because nothing can anabolically build them up. What's interesting is the non-essential amino acids can almost turn into each other. Things like methionine and cysteine, the two self-containing amino acids, they can turn into each other in a series of metabolic processes, which I'll go through in later videos. They can turn into each other. So is that catabolic or is that anabolic? Me personally, I'm not even sure. I just wanted to sort of explain the difference between the two in the most basic sense possible. I assume because cysteine is the more basic amino acid in terms of chemical structure, I'm going to say that is a anabolic process because it builds up a more complicated molecule. Things have to be done to cysteine and things have to be added to cysteine. Carbons have to be added to cysteine to actually get methionine. So I'm going to consider that a build-up. The more complicated the thing is, it's going to have to have been built up from certain molecules, unless it's been ingested from an external source, such as the diet. You probably would have heard of things such as anabolic steroids. They probably it could be called an anabolic steroid because it literally helps the build-up of muscle, but on a more scientific level, it's probably because it helps the production of these non-essential amino acids that are used inside of muscle cell build-up and making to actually mean that these muscle cells can be built and your muscles can grow bigger. That's probably what an anabolic steroid does, helps with these processes by injecting certain molecules into your body that, while have that effect, will have many others as well as that. That's what a lot of things happen to the body while you get big muscles. There's also a massive trade-off in your general health overall. That's about all I wanted to say, I think. Hope you now understand the difference between the two things, and with that, I recommend subscribing because I love this community with young tribal people who are willing to improve themselves. So much more than they already have, and good luck.